Hi all, welcome to my channel EC Electrical Engineering and Electrical Engineering Simplified. In this video, I am going to explain important MCQs in all units and control system. This is my first video including all topics in control system. I have named as Set 1. Each set consists of 20 questions and answers. Next, I will try to list set 2, set 3, so on shortly. If you completed all sets, it is very easy to get full marks in all types of competitive examination. Keep on watching. Watch the video completely. Please share, subscribe and comment my video, then only I can improve. The problem number 1, the steady state error of a stable type 0 unity feedback system for a unit step function is, where Kp is the position error constant. Type 0 system. So first of all, I am going to write the type 0 system. G of s is equal to k by s plus 1. What is type? The power of separate s in the denominator is known as type. This is the type 0 system. I am going to find out the steady state error. For a unit step input, the steady state error may be 1 by 1 plus Kp. So what is Kp? Kp is the positional error constant for the step input. Kp, how to find out this? Limit s tends to 0, g of s. Limit s tends to 0. What is the value g of s? K by s plus 1. That is Kp. I have to substitute s is equal to 0. So the answer may be Kp equal to K. So what is ES? 1 divided by 1 plus Kp. Option B is the correct answer. Next problem, an electromechanical closed-loop control system has the following characteristic equation: s cube plus 6k s square plus k plus 2 into s plus 8 is equal to 0, where k is the forward gain of the system. The condition for closed-loop stability is, the stability is normally determined by Routh stability criterion. Routh stability criterion. So what is Routh stability criterion? First of all, have to put s cube, the maximum power, then s square, then s, and then s power 0. Then have to put the elements here. That is the coefficient of s cube 1, coefficient of s that is k plus 2, here s square 6k and here 8. And next I have to find out the s values. Here cross multiply this 6k into k plus 2 minus 8 the whole divided by 6k. And see here, multiply this 0 into this 0 divided by 6k into k plus 2 minus 8 divided by 6k. So I'll get the answer 8. What is the condition for stability using Routh stability criterion? The first column element should be positive. Already 1 is positive, 8 is positive, but we don't know 6k and the next term 6k into k plus 2 minus 8 divided by 6k. All the column elements should be greater than 0. So 6k, this positive means greater than 0. 6k is greater than 0 and 6k into k plus 2 minus 8 divided by 6k, that is greater than 0. Now I have to expand this 6k square plus 12k minus 8 divided greater than 0. Divided by 2. So 3k square plus 6k minus 4 greater than 0. Now I have to use minus b plus or minus square root of b square minus 4ac divided by 2a to find out the root. So minus 6 plus or minus square root of 36 minus 4ac. So already one minus, here and minus is there. So plus 4 3s are 12. Here 4 is 4 AC. 4 into 4 that is 16. 16 into 3 that is 48. Plus 48 the whole divided by 2a. So 2 into 3 6. So minus 6 plus or minus square root of 84 divided by 6. So that is minus 6 plus or minus 9.165 the whole divided by 6. One answer is positive and next one is negative. Have to take the positive one only, so that will be the correct answer. So 165 divided by 6. So the answer is plus 3.165 divided by 6. The answer may be 0.528. The positive answer is correct because the value is greater than 0. So k is equal to 0.528. That is the correct answer. Next problem, problem 3. The transfer function of a closed loop system is T of S is equal to k divided by S square plus 3 minus k into S plus 1, where k is the forward path gain. The root locus plot of the system is. Here, first of all, I am going to take the characteristic equation. What is characteristic equation? Denominator polynomial that is equal to 0, that is the characteristic equation. So, numerator polynomial. So, d of s, what is d of s here? S square plus 3 minus k into s plus 1 equal to 0. First of all, have to put the value k is equal to 0. So s cube plus 3s plus 1 equal to 0. Here I have to find out the roots of this equation. So minus 3 plus or minus square root of b square, that is 9, minus 4ac 4 divided by 2. So minus 3 plus or minus square root of 5 divided by 2. So minus 3 plus or minus square root of 5. Square root of 5 is 2.236. I got two answers here, 2.62, then minus 0.38. This is for k is equal to 0. Next I have to substitute k is equal to 1. So k is equal to 1 in this equation. So I'll get the new equation s square plus 2s plus 1 the whole square. So what is s square plus 2s plus 1? That is s plus 1 the whole square, that is equal to 0. So s may be minus 1 comma minus 1. Both are minus 1. And next I have to substitute k is equal to 3. So when k is equal to 3, the characteristic equation may be, have to put k is equal to 3. So s square plus 0s plus 1 equal to 0. So s value is plus or minus j. S is s square equal to minus 1. S is equal to plus or minus j. Then I have to put k is equal to infinity. That is the last value. So I have to write the same equation, s square plus 3 minus k into s plus 1 equal to 0. Have to divide the whole equation by 3 minus k. So what is the new equation? S square by 3 minus k plus s plus 1 by 3 minus k equal to 0. So s is equal to what? Now I have to put k is equal to infinite. So this term will be 0. This term also 0. S may be 0. So s value is 0 now. Okay. See this 4 options. The option B is the correct answer because when k is equal to 0, one of the value is minus 2.62 and minus 0.38. Here minus 2.62 and minus 0.38. And next here k is equal to 1, here minus 1. And k is equal to 3, j and minus j. So the option B is the correct answer. Next problem, the transfer function of a simple RC network function as a controller is. GC of S is S plus Z1, S plus P1. The condition for RC network to act as a phase lead controller is. Normally, for a phase lag compensator, the phase lag compensator, pole first, zero next. So this is the way to remember phase lag compensator. So inverse of phase lag compensator is phase lead compensator. In a phase lead compensator, zero first, then pole next. So in this way, you have to remember this. It is easy to find out. So first of all, I have to draw the diagram sigma plus j omega. Here 0 first, Z1 and pole next, P1. So which one is more? P1 is more than Z1. P1 is more than Z1, greater than Z1. That is the correct answer. Next problem, in the signal flow graph of figure, the gain C by R will be. In a signal flow graph, how to find out the overall transfer function? The transfer function is equal to, here P1 delta 1, how many forward path? P2 delta 2 and so on, here divided by delta. So what is P1? P1 is the forward path number 1. See, forward path is the path that starts from, the signal starts from input and ends at output in the right, left to right. Okay, so 2 into 3 into 4. So this is the forward path transfer function. 2 into 3 into 4, that is 24. Then next forward path is, see, this is the next forward path. So P2 equal to 1 into 5 into 1, that is 5. What is the transfer function? TF is equal to, there is no other forward path other than this. So P1 delta 1 plus P2 delta 2 divided by delta. Next I am going to find out delta. So what is delta? 1 minus sum of individual loop plus sum of two non-touching loops, so minus sum of three non-touching loop and so on. So first of all, I am going to find out loop 1. So see, this is the loop 1. A node which is having the outgoing as well as incoming branch, that is known as loop. So minus 2. The next loop is loop 2. Here 3. Then this is minus 3. What is the loop number 3? That is 4 into minus 1 minus 4. And what is loop number 4? See, this 5. This is the loop number 4. So 5 into minus 1 into minus 1. Minus 1 into minus 1, that is minus 5. And two non-touching loop. The loop number 1 and loop number 3, 2 are the two non-touching loop. So I have to multiply. So I'll get L5, that is a non-touching loop. Minus 2 into minus 4, that is 8. Okay, now I am going to write the value delta. So delta equal to what? 1 minus sum of individual loop. So minus 2, minus 3, minus 4, minus 5 and sum of non-touching loop plus 8. So 1 plus minus 5, 10, 14 plus 8, that is 23. So delta value is 23 and next I am going to find out TF. So TF is P1. P1, what is P1? P1 is 24. What is delta 1? Delta 1 means same as delta, that is not touching in the kth forward path. So the first forward path, here forward P1 is the forward path number 1. Here all the loops are touching in the forward path. So 1 minus 0. And next take P2, 5, 1 minus. Here second, this is the second forward path. Here one of the loop, this loop is loop number 2 that is not touching in the second forward path, so I have to take into account. So 1 minus of minus 3, that is plus 3, divided by 23. Already I got it. So transfer function equal to 24 plus 20 divided by 23, that is 44 divided by 23. Option D is the correct answer. Next, problem number 6. A second order system has a transfer function given by g of s is equal to 25 divided by a square plus 8s plus 25. If the system initially as stressed is subjected to unit step input at t is equal to 0, the second peak in the response will occur at. First of all, I am going to equate the transfer function with the general second order transfer function. The general second order transfer function is omega n square divided by s square plus 2 zeta omega n s plus 25. So compare both the equations. So omega n square equal to 25, omega n is plus or minus 5 radians per second. Have to take the plus value. And next take the 2 delta omega 2 zeta omega n is equated with 8. So 2 zeta omega n is equated with 8. Cancel this 4 and zeta equal to 4 divided by omega n. What is the value? 4 divided by 5, 0.8. Okay, this is the zeta value. Here what question asks? Second peak, second positive peak. That is very much important. Second peak means that is the positive peak. See, this is the second order transient response, time response in the second order system. And see, this is the peak number 1. This is peak number 2. And this is the peak 3. Okay, second positive peak. Peak is 3. N is equal to 3. So now I am going to find out the peak. Tp equal to n pi divided by omega d. What is n here? N is the second positive peak, 3 into pi. What is omega d? Omega n square root of 1 minus zeta square. So 3 pi divided by omega n is 5, 1 minus zeta equal to 0.8 square. So 3 pi divided by 5 into 0.8, the square is 0.64. So 1 minus 0.64 is 0.6, that is 0.36. Square root of 3 is 0.36 is 0.6. So 5 into 0.6. So 3 pi divided by 3, the answer may be pi. So 5 is the correct answer for this problem. 5 seconds. Next problem, the open loop transfer function of a feedback control system g of s and h of s equal to 1 by s plus 1 the whole cube. The gain margin of a system is. First of all, I am going to find out the gain margin. So what is gain margin? Gain margin is inverse of magnitude at phase crossover frequency. Inverse of magnitude as phase crossover frequency. So here, first of all, I am going to find out the magnitude. So g of s into h of s equal to 1 divided by s plus 1 the whole square. I have convert this into sinusoidal form. So put gs is equal to j omega. Now g of j omega equal to 1 by j omega plus 1 the whole cube. Okay, next I am going to find out the magnitude here. So how to find out the magnitude? Square root of j omega is omega square plus 1 the whole cube. Okay, that is equal to 1 divided by omega square plus 1 the whole power 1 by 2 the whole cube. Can we write like this? 1 by omega square plus 1 the whole power 3 by 2. Okay, this is the magnitude. Next, I am going to find out the phase angle. So, phase angle is g of j omega is 1 by, I have to rewrite like this, j omega plus 1 into j omega plus 1 into j omega plus 1. Here I am going to find out the phase angle g of j omega. So for the first term, that is minus tan inverse b by a. B is omega. Second term minus tan inverse omega. Third is minus tan inverse omega. So summed up all, so minus 3 tan inverse omega. Next, the frequency at which the phase angle reach minus 180 degree, that is known as phase crossover frequency. The frequency at which phase angle reaches, phase angle means what? J of j omega that reaches minus 180 degree, that frequency is known as phase crossover frequency. So minus 180 equal to minus 3 tan inverse omega. Now I have to cut this. So tan inverse omega equal to 60. So what is omega? Omega equal to tan inverse tan of 60. So tan 60 is root 3. So omega equal to root 3. So omega equal to omega PC, that is a phase crossover frequency. What is gain margin? Inverse of magnitude at phase crossover frequency. Now I have to substitute this in the gain margin. 1 by, what is the magnitude? 1 divided by omega square plus 1, the whole power 3 by 2. Now I have to substitute 1 divided by, what is omega PC? That is here PC. Omega PC is root 3 square plus 1, the whole power 1 by 2, the whole cube. So what is the answer? 1 by square root of 3 whole square is 3. 3 plus 1, 4. 4 square root is 2. So 2 cube. 2 cube equal to what? 1 by 8. Sorry, 1 by 8. The answer is 8. So 8 radians per second. Sorry, not 8 decibel. Not radians per second. 8 decibel is the correct answer. So option D is the correct answer. Next, problem number 8. A unity feedback control system has an open loop transfer function g of s is equal to 4 into 1 plus 2s divided by s square into s plus 2. If the input to the system is unit ramp, the steady state error will be. If the input to the system is unit ramp, that is velocity error constant kV. And what is the steady state error? The steady state error may be 1 divided by kV. kV is the velocity error constant. How to find out this? kV is equal to limit s tends to 0, s into g of s. Okay, so kV equal to limit s tends to 0, s into, what is g of s? That is given 4 into 1 plus 2s divided by s square into s plus 2. The s get cancelled and put s is equal to 0, we'll get the value as infinite. So what is es is? Es is equal to 1 by infinite. The answer is 0. So option A is the correct answer for this problem. Next one, the characteristic equation of a feedback control system is given by s cube plus 5s square plus k plus 6 into s plus k is equal to 0, where k is greater than 0 is scalar variable parameter. In the root loci diagram of the system, the asymptotes of the root locus for large value of k meet at point in S-plane whose coordinates are. So this is the characteristic equation given. I have to write it. First of all, I have to expand this 5s square plus ks plus 6s plus k equal to 0. Then have to separate the k. S cube plus 5s square plus 6s plus k into s plus 1 equal to 0. Divide the whole equation by s cube plus 5s square plus 6s plus, so s cube, what is the new equation? 5s square plus 6s plus k s plus 1. Have to divide this, this is the first part and this is the second part. Divide it by s cube plus 5s square plus 6s, and this is divided by s cube plus 5s square plus 6s equal to 0. Normally, what is the form of characteristic equation? 1 plus g of s into h of s. So this is the unity feedback. So 1 plus g of s equal to 0. So in this equation also 1 plus k into s plus 1, the whole divided by, have to take s outside, s square plus 5s plus 6 equal to 0. From this equation, what is g of s? G of s is equal to k into s plus 1, the whole divided by s into s square plus 5s plus 6. I have to rewrite this as s plus 1 divided by s into s plus, have to separate this, s plus 3 into s plus 2. Okay, next I am going to find out the asymptote for this equation. So the asymptote is what? Asymptote is sum of poles. Sum of poles minus sum of zeros divided by number of poles minus number of zeros. Sum of poles. So what are the poles here? Yes, 1, 2, 3. 3 numbers of poles. 3, and sum of poles is 0 minus 3 minus 2. Number of 0 is, how many numbers of 0? There is only one 0. So 0, 1, 1, and in the numerator that is minus 1. So minus of minus 1. So minus 5 plus 1 divided by 2. So that is minus 2. What are the coordinates here? Coordinates are minus 2, 0. So option B is the correct answer for this problem. Next problem. Problem number 10. A linear second order single input continuous system described by the following set of differential equation: x1 dot of t equal to minus 2x1 of t plus 4x2 of t, x2 dot of t equal to 2x1 of t minus x2 of t plus u of t, where x1 of t and x2 of t are the state variables and u of t is a control variable. The system is, okay, check the system is controllable and stable or not. Okay, now have to find out the matrix form of x state variable equation. X1 dot x2 dot equal to minus 2, next 4, here 2 minus 1, here put x1 x2 and then plus, first is 1 0, there is no u of t, and second u of t is here, u of t. First of all, I am going to verify whether the system is controllable. How to find out the controllability matrix? QC equal to B, then A power n minus 1 into B. What is n? N is the order of the matrix A. N is equal to 2. So B in B, then colon A into B. First of all, find out A into B. A into B. So what is the A matrix? A matrix is minus 2, 4, 2, minus 1. B matrix is 0, 1. Multiply this, minus 2, 4. Minus 2, 4, 2, minus 1. So minus 2 into 4 multiplied with 0 and 1, we get 4 and minus 1. Here I have to put the values here. B is equal to 0, 1, 4 minus 1. So now I have to multiply this. I get the value that is minus 4. What is the order of the rank of the matrix? Rank of QC equal to 2. The rank equal to the order of the matrix. So the system is controllable. System is controllable. Next, I am going to check whether the system is stable or not. For stability of the system, first of all, I am going to find out the characteristic equation. After getting the characteristic equation, have to check the system is stable or not by using root stability criterion. How to find out the characteristic equation? Si minus A equal to 0. So S into I. I is the identity matrix 1 0 0 1 minus what is A? A is minus 2 4 2 minus 1. Now S plus 2 minus 4, here minus 2 S plus 1. So S plus 2 into S plus 1 minus 8. And now I have to expand this. S square plus 3s plus 2 minus 8. So what is the characteristic equation? S square plus 3s minus 6. So from this characteristic equation, we can say that the first column of the row array is not positive. Just have to verify this using root stability criterion. S square, then S, then S power 0. S square is what? 1, then minus 6, then next one is 3. Now I have to multiply this. 3 into minus 6 divided by minus 0 divided by 3, that is minus 6. See, the first column of the root array is negative element is there. So this is the unstable system. Not a stable system, this is unstable. So this is the controllable system, but it is the unstable system. Option B is the correct. This problem, a process with open loop model g of s is equal to k into e power minus s dy divided by tau s plus 1 is controlled by a PID controller. For this process, the integral mode always improves the steady state response and derivative mode that improves the transient response. Here integral mode improves the steady state performance. Option B is the correct answer. Derivative mode improves the transient performance is correct answer. Option B and option C both are correct answers. Second, 12th problem. A linear discrete time system has a characteristic equation z cube minus 0.81 z equal to 0. The system have to write the equation z cube 0.81 z that is equal to 0. Have to take z, so z square minus 0.81 equal to 0. Z is 0 or Z may be plus or minus 0.9. Now I have to draw the unit circle. Here this is the unit circle. In a unit circle, 0, this is the unit circle, no. 0 is within the unit circle, 0.9 is within the unit circle, 0. minus 0.9 also within the unit circle. So the system is stable. All the roots are within the unit circle. So we can say the system is stable. Problem. If s cube plus 3s square plus 4s plus a equal to 0, then all roots of this equation are in the left half plane provided that. Here I have to use the root stability criterion to find out the stability and what is the condition for A. So first write S cube, then S square, then S power 0. S cube, have to write the value 1, then 4, 3, then A. Here cross multiply this, 3 fourths are 12 minus A divided by 3. Here cross multiply this into this minus 0 divided by the same term, we get A. So A is greater than 0 is a condition. The first column element in a root array should be positive, then only the system is said to be stable. So 12 minus A divided by 3 is greater than 0. So 12 minus A is greater than 0. So A is less than 12. So what is the condition here? A is greater than 0 and A is less than 12. So option C is the correct answer. A is between 0 and 12. Next, problem 14. Signal flow graph is used to find stability of the system, controllability of the system, transfer function of the system, poles of the system. Transfer function of the system is the correct answer. Next, the step error coefficient of the system G of S is equal to 1 by S plus 6 into S plus 1 with unity feedback is step error coefficient. So first of all, we should know what is the step error coefficient. This is the positional error constant Kp. This is the step error coefficient. What is the ramp error coefficient is the Kb, velocity error constant. This is the positional error constant. I am going to find out Kp. Kp, the formula is limit S tends to 0. G of S is the correct answer. So limit S tends to 0. G of S is given S plus 6 into S plus 1. Have to put the value 0 here. I'll get the answer 1 by 6. So option A is the correct answer. Next problem, the final value theorem is used to find the steady state value of the system output, initial value of the system output, transient behavior of the system output, none of this. The option A is the correct answer, steady state value of the system output. Next problem, for a second order system, damping ratio is given 0 is less than zeta is less than 1. Then the roots of the characteristic polynomial. The roots of this is the underdamped system. Underdamped system, zeta is less than 1. So this is the underdamped system. So in underdamped system, the roots of the characteristic equations are complex conjugates. So option C is the correct answer. The transfer function of a linear system is the first one ratio of the output and input, ratio of derivative of the output and input, ratio of Laplace transform of output and that of the input with all initial conditions are 0. Option C is the correct answer. Next problem, e power at can be expanded as. So how to expand e power at? E power at equal to 1 plus at by 1 factorial plus at square by 2 factorial plus at cube by 3 factorial up to what is the last term? At power k the divided by k factorial. So a power k into t power k divided by k factorial is the correct answer. Option B is the correct answer. Next, non-minimum phase transfer function is defined as the transfer function which has zeros in the right half of the S-plane, which has zeros only in the left half of the S-plane, which has poles in the right half of the S-plane, which has poles in the left half of the S-plane. But the option A is the correct answer, which has zeros in the right half of the S-plane. Thank you. Have a nice day.